Hello. Tonight's topic is about my painful experience with dirty code and how that led to a step-by-step process to make it clean again. A three-step process to make it clean. So before I start, let's talk a little bit about myself. I'm a freelance full-stack developer. I have a background with AngularJS back from the day, and .NET development, and I also do some DevOps. So I do a lot of different stuff, but Angular development is my primary stuff I do. I also have a blog where I blog mostly about Angular development, so go check that out. I blog almost like once a week, so check that out. And my GitHub for mostly also Angular code, and go follow my my Twitter, where I will come with updates. So let's start with a couple of hands up. So hands up, who thinks refactoring code is important? Hands up. That's a couple of people. Who is allowed to spend time on refactoring by the client or boss? We like doing 50-50 here. That's interesting. And who has code that needs to be refactored? All right, everyone, hands up. So that leads us to this topic of the day. And let's look at the real motivation behind clean code. So the thing is that should you optimize for getting the code done as fast as possible, or should you optimize to make it clean and intentful and communicate what it's doing? So code is read way more than it's written. So that's why you should definitely optimize for keeping it very clean and read optimized. You want to optimize for clear and effective communication. And this talk is going to go in depth with how you're going to follow a step-by-step process to keep it clean. And we're going to go to the code level to ensure that you keep the code clean. So let's look at why does code rotten. I'm sure that no one has made the plan. Let's make this component 2,000 lines, and let's call the variable x and y. And let's not understand what's going on anywhere. I think no architect will plan that out. So why does code rotten? And from the book Clean Code, there's this metaphor of the broken window. If you see an abandoned building, the point where people just completely lose respect of that building is when the windows start breaking. That's like when it hit this critical point where there's no respect for the building anymore. It's like full of graffiti, and people are even just stealing stuff without even caring because it's completely broken anyways. So it's the same thing with code. You hit this critical point of dirtiness in your code where people don't respect it anymore. It's like, but look at this other code. It's completely it's completely dirty anyways. So why should I be the one who is doing all the hard work and making this clean all of a sudden when we have like 10 years of legacy code behind us? And the real motivation is bad code kills, actually. We have this accident with Toyota that has an accident where the fail-safes, the thing that is controlling the acceleration, broke. And that was due to spaghetti code. So there you have it. Your bad code might kill somebody one day. And let's look for why is there still, if it's so dangerous to make bad code, why is there still much bad code? If you start a new project, you can almost expect that there's going to be a lot of some bad code, or some. It depends on where you're coming from, but yeah, there's also going to be always going to be some legacy code, and this is the objection that I tend to hear. First of all, let's see. First one, I'm just going to do this later. Oh, I'm really busy right now. I'm just going to do this later. I'm going to have time later. And the thing is, you never have time. You never have time. You think you're going to have time after this big release. Now you have time to make it all clean and make it all good again. But guess what? It's never going to happen. And the best thing to do is to prevent it to get dirty in the first place by incorporating this in your daily work instead of just having this big refactoring job at the end of a release. You have this cycle where you have a very quick release, and then things just start to go slow because now you don't understand the code anymore. It's full of bugs, and you change something one place and it's breaking the other place. And the other thing is, my boss won't allow me. You maybe have a boss that won't allow you. You're not allowed. Also, like 50% of people here were not allowed to refactor or any objections like that. And my response to that is that you should be faithful to your craft, just like a lawyer and a builder and a doctor would. If you go to the dentist and be like, can I get this a little cheaper? Maybe if you just don't clean the equipment. Can I get this a little cheaper? Because I don't want to pay for all that. And if you just want that, he will definitely, if he had any respect for his job, he will say, no, this is how I work. This is my craft. I don't do that. It will have all kind of side effects on you if I were to do that. The same is with dirty code. If you do bad code, you're gonna create all kind of side effects in the code, and it's like your job to communicate and be like, this is your craft, and stand up for that. So now we come to the Angular specific, my 3-step process of refactoring an Angular. When I come in and I see it's very dirty, this is my secret weapon. Well, now it's not really secret anymore, but you can have it too. This is 3 steps I go through. Normally, what I start seeing is I see 2 big components. I've seen components with like 2,000 lines, and they contain all kind of different logic. It's business logic, it's all kind of stuff, and it's all one big spaghetti. You don't know what belongs where. So when you look at the code and like, oh, what's this part belonging to? I don't know. But it's just these big components. Then you want to break these components into what's called smart or dumb components. There's some different names for that. You can call them container or presentation components. I like to call them because that's what it is. We have the containers that is delegating and controlling, and then we have a presentation that is containing presentation logic and it's showing the actually presentation. And after that, you want to delegate. You want to slim the components down as much as possible and keep the logic inside of services. So what I like to do is I like to put it into what is called, you know from MVP pattern, with these presenters containing logic for the components. I also like to call them just component services, dedicated services for a component. And then they start to become too big. I make the critical point at around 500 lines of code in the services, and then I break them up again to smaller services. So this is like my process, and this basically I do it all over, and it's an iterative process. You keep doing this, and you don't like try to plan ahead. You just do this when you run into trouble, when you like hit that critical point. Oh, now it's hard to work with this component again. Then I'm gonna follow the step process, and eventually it will be all good again. I've seen very hard cases that have been fixed by this, so it works. The first step is you gotta split this. You have a huge component. Let's say it's 2,000 lines and containing a big template containing a lot of logic inside of the component, and you start splitting these up. So you have the container part that is injecting services in. This here you're delegating for the HTTP calls and injecting other services in. And then you have a presentation part, which is called, which is containing input and outputs and contains presentation. So it would look something like that. For example, for a blogging application where you have the container part here. Container part is doing the injection of the services. And then you're gonna have all these presentation components that is communicating with inputs and outputs. And also one thing I thought, if presentation is dumb component, does that mean that UXs are dumb? Are there? So let's look at a container component. We have a container component here. You can see it by that it's injecting a service. So it's doing some kind of delegation here. And it can contain inputs as well, but that is delegating. That's the job of this component. And you see here that I'm also doing this view providers setup here, where I'm hooking up the dedicated service that is containing all the business logic for this component, so we can just delegate and keep this very slim. And when I look at this, it doesn't take a lot of time to just see what's going on. It's very easy. When they have the presentation component, we have the change detection. That we have the benefit here, but we can do change detection on push, and that is because we only have inputs and outputs. And that's how if you do on push, you will limit the amount of renderings this component will have, because it's only going to render if the input is going to trigger a new reference, and if you're going to do some event inside of this component. So it can be a performance boost to have this set up here. And yeah, you're gonna delegate. You're gonna move outputs up to the container component, so it can handle the save logic. It can call the SSP service and do all that. So the next step, when you have these two split up, you want to create these dedicated component services to just slim down the components, just make them as small as possible. And you do that for container components, and I also do that for presentation components. And you can argue, is it still a presentation component? Well, you don't do it. You're only delegating the presentation logic, just again to keep it very small and have a clear split of what is like the control mechanism, and what is like more the business logic part. And then the last part, when your dedicated component service are getting too big, you want to split them up into smaller component services. And then it's up to you what kind of split you want. It's kind of a creative decision to how you want to slice the cake, because it's not that easy all the time to find the slice. But when you get too big, you'll find some way of slicing it up. And I see it around 500 lines of code, then I'm starting to look into how I can slice it up. When it exceeds 1,000, I'm definitely going to look to slice it up and move the logic to a more central place where the logic should belong. So let's look at how this is done for an example. Here I have my to-do application. You can complete stuff. You can. It's Danish. You can change the language. You see it here. So it's a pretty simple app, but it's to demonstrate how this process works. And you can see how the old architecture of the app was, but we had this kind of big component here. It's not that bad because it's a simple app, but it is to demonstrate how this might grow into something you don't want to maintain and make it nicer. So the first thing is we have this big component in the refactored edition. Now we have this. It's turned into this now, where we took all we looked at all the parts and made a decision: does it belong to presentation or does it belong to some delegation logic? And if it's presentation, it's going to go down here. So it's going down here. We slimmed down actually the whole template, so it's just delegating all the way down here. And now it's containing the template here, and it's going to do on push here because it's very easy to set up here and ensure that we render correctly when these inputs changes. And yeah, the next part is that once this happened, we still had kind of a lot of logic here in the component. We want to slim that down even further. So we see that I'm delegating everything to a dedicated service, and I do that with view providers. And there's providers and there's view providers, and the benefit with view providers is that I don't want like content children to be affected by this. I only want what's inside of this, including view children to this service to provide for. And what's going on here is it's delegating everything. Everything you saw here, it's just delegating. So the thing is, when I'm looking at the logic, I can just look at it here, and it's very, very clear what the use case is doing. When I want to look into the logic behind, I go in here, but I don't need to be cluttered by the logic all the time. I also did this here where I had the same case. This is pretty much too small to justify to split it up in container components and presentation components, but if it grows, I might do that. And then the dedicated service is going to contain some of the logic. Again, it's very simple here, but that's just to ensure that it scales. So let's look into refactoring on the code level. So there's two good books I would recommend. I saw you had the clean code cheat sheet over there. It's very good. It's very good to just look up and know what you're doing wrong. I would recommend this one definitely, and clean code is also good. They have some clear principles around how you should structure your code on a very code level. Not as abstract as just the solid principles. This is really goes in depth with how to do it. And I want to incorporate this knowledge into some important points about what you can do now to write cleaner code. So as you know, you should optimize for readability, and it's kind of the same thing as the CQoS pattern you see on the back end, where you optimize for faster read performance because an web app is doing more reads than writes. So it makes sense to optimize for the more used operation. Same thing in code. You're just doing a lot of read, you optimize for read. And if you need comments to explain how the code is not clean, so if you need to, you see a big block of just explaining this is going on down here, then you know it's not clean, and you probably just should refactor it. But if it's like this is a hack, this is why this is doing. I know this is a little weird. This is why this code is happening here. That's totally all right. That's why, and that's what comments are for. And the brain can only contain around 7 things simultaneously. So you want to optimize for that. When you look at a method, you shouldn't have a big cognitive overload for having a lot of different things at the same time, and juggling at the same time in your head. So you should limit this to around 7 concepts in each method, in each class. This is like the level of abstraction. If you get more, you just break them down, so it's at every time it's not more than that to work with. And then the 3 seconds rule is, when you look at a method and you look at a class, it should be so self-explaining that you don't need more than 3 seconds to just know what's going on. So the third thing is self-explaining method names. And a method should just explain what it does without needing to look into the code. Again, if you need to look into the code and go white box with it, then it's something bad. And you either explain what it returns or the side effect. I'm going into that later, the command query segregation, why you should split that up into 2 parts. But when a method is just user, I have no clue what's going on. Is it going to create a user? It's going to get the user, get user ID. Now I know. On change, it's like, I don't know what's going on. It's probably something that's written very fast. Username update, if it's not like that, I know what it is, and it's just communicating either what it's returning or the side effect without a need to look into the code. Then the command query segregation. This is related to well-named methods where you want to keep it very separate if it's querying or if it has a side effect. And let's look into what's a side effect. Well, a side effect is then the method is changing some external state outside of the method. So every time you do that, you don't want to call a get method, and then that get method is gonna change some external state. That's gonna be confusing. You're gonna be like, I don't know what's going on. I don't feel safe about this code anymore. So, for example, if you have a counter here that says get next count, and that's increment the counter +1, then you need to look into this method to know what's going on, and that's bad. So instead you split them up into something like get next counter, and then the command here that is setting the next counter. Having this set up, it just makes it easy to see, And where do you think the most errors happen? Is it in the querying of stuff, or is it in the modification?
Query.
No, it's in the modification. It's when you query it just call an let's say you call an SSP get method. Nothing bad can really happen. You can call it 1,000 times. Nothing bad will happen. But when you start modifying stuff, that's where the errors tend to happen. So if you have that clear, then you know where to look when you need to debug stuff. Oh, we have this method that's modifying the state. Now I'm going to look into that. And self-explaining variable names. A variable should explain the value it holds without any ambiguity. Also, you tend to see stuff like as short names that don't really make sense. You see something really bad like X and Y. That makes definitely no sense. And so if you have some user ID, you could say a bad example would be user ID or UID. UID maybe if it's a very common shortening of the word, or otherwise you wouldn't know what's going on, so you might just stick with some explaining variable name. It'd be very easier, especially for new people on the team. They can just read that, and it's going to be very easy to know what's going on. And then a consistent level of abstraction is very important, and that's the 3-second rule I talked about before. So to obey that, you need to have a consistent level of abstraction. If you work very low level, if you look at like an assembly program, it will take a lot of time to know what's going on because it's way too low level. So you want to keep it a consistent level of abstraction where for every level there's around 7 concepts. It takes a maximum 3 seconds to know what's going on. That's how you want to break it all up. And you can have it like here where you start doing some use case method here, and then you do the HTTP client directly, or you could do some WebSocket directly, or something more lower level. If you mix that, then what's else? Well, there's gonna be a lot of like lower level stuff here. It's naturally gonna grow too big, and it's gonna be inconsistent. You're gonna be confused. Why is this use case method being called here, and then we're going lower level here? So what you want instead, if this you see this, then you need to wrap this into some equivalent level of abstraction that is equivalent to the use case levels here. So if this is a use case level method, you want to make this a use case level method and just take all the lower level code and move it into some use case. If it's low level code, you want to take keep it pure low level code. So in Code Complete, there's this 3-step process of writing clean code. And the first step is that you start with writing pseudocode as comments before writing the actual code, which will just make you abstract a little bit away from the actual code and just think about the use cases. Do this, do this, do this, very simple. And then you replace the comments with equally well-named methods. You should not lose any meaning from the methods. I think it's okay sometimes to keep the method a little longer if it actually explains what's going on. If it just keep it short, because I don't want that long, it's too wide for my screen, I don't care. It should explain what's going on. And then you should implement the method using the above guidelines, using a consistent level of abstraction, command query segregation, and such. And then one last thing is regarding refactoring style and formatting. Some people are very religious about the tabs versus spaces and all this style stuff. And my opinion is that if it can't be automated, don't even bother, because it doesn't really matter. The only thing that matters is that it is consistent. And you just decide on something and just roll with it and just keep it consistent and just use some formats. So like if you search T.S. Lind and Pretty, you'll probably find my blog post where I show my setup of how I'm setting this up to make it work together. And this is just, you just save and you just format in VS Code, and it will take care of anything. So before, when you need to like fix tabs and stuff manually and fix either you use double quotes or single quotes, now you don't need that anymore. You just follow the automation. That's what I have for you. Do you have any questions? Yeah?
I have some input regarding the writing the pseudocode in comments, I actually, if possible, I like to start with a test, and I actually write part of the logic that I can in a unit test, and that, for me at least, it's enough to start to make the code that passes my test, and then change my test to expand on the business logic, and then change my code and so on. As it's test driven.
Yeah, you can definitely mix this with TDD. You can do the test first, then you can do the comments to just ensure that it's going to be very clear, and then you can just fill out the gaps. And you don't need to do this like all the time. You do this when it's maybe getting more complicated, and you still want to ensure that you're keeping stuff simple, because that's really the key here, to keep stuff simple. If you start doing it too hard for yourself, a lot of applications there are actually pretty simple when you look at the basic business logic, but it just made very complicated with all kind of by violating all these rules, basically. Yeah.
You talked about splitting big components into more small
yeah.
Could you end up having a lot of components and then quite a confusing project structure, having a lot of files, the TS, the XML, eventually
So as you saw in the demo, I'm not going to do this like a robot that's going to do it without thinking. I'm going to do it when it hurts. And so when I see a component gets too big, that's when I'm going to chop it up. If a component is like 20 lines, it's going to be a big hurdle to start splitting it up and stuff. I agree. So you want to be pragmatic about this.
So do you ever consider, you had a slide where you talked about smart and dot components or presentational container components. And there was a slide that said a container component and a presentation component. Do you ever consider doing a container component with several presentation components, so they're reusable, the view part of them are reusable?
Definitely. So when I have a lot of these, I'll probably have a lot of these in the shared components in an app. You'll probably have a lot of these, and you want to keep them presentation component, keep these separate, because as you said, it's very easy to reuse. If you have a lot of, you're gonna do a lot of Redux stuff inside of there, you're gonna make it harder to reuse. If it's just very bare bone, you have it looks like this, and you have to take these inputs and outputs. It's very easy to reuse. So yeah, definitely. But again, the reuse part is something I'm gonna do later. So it's like when you refactor anything else, when you see you start repeating yourself, that's when I will move it into the shared. And then I will ensure that it is a presentation component. I can just use both places. But yeah, when it hurts. Yeah.
Also, a table would be a good example where you could have one container component for the state that kind of let the state flow down to all of the cell components and row components and the main table components. I'm curious, Christian, could you point out a place in your code where you think that a use case is the most identifiable, with the highest level of abstraction in your example app there?
Highest level of abstraction is it's going to be at the container. So it's going to be like this: delete a to-do item and edit a to-do item. That's pretty high level. I guess that's like the upper level. That's the use case. If you were to do the use case diagram, that's how it starts. And when you look at the component, I just want to make that crystal clear that this is the use cases. And then if you want to look into the business logic, there's the service. And you want to look into the presentation, go to the presentation. Yes, anyone else?
Excellent. Give it
That's
up.
it. There you go.